Okay, we've got this crazy triangle here to deal with, and let's take a look at some of the information that we've got. We know that ACB is a right angle, so I'm going to just go ahead and label that as a right angle like that. Okay. We also know that CD and CB trisect it, so that 90-degree angle gets split into three 30-degree angles, which I will mark up like this: flump and flump and flump. Okay, so those are 30. All of those are 30. 30 means, green means 30 in this case. So flump like that, and like that, and like that. Okay, those are all 30 degrees. Cool. Which means that there may be a 30, 60, 90 triangle in the offing. So let's also label some of our sides. So we can label AC as 5, kumquats, gerbils. BC is 12 somethings, which, of course, means that BA is 13 somethings. Okay, so that's a 5, 12, 13 triangle. Now, a useful thing for us to do would be to draw a perpendicular from E to CB. Okay, we're trying to find CE, which is this segment here. We're going to draw a perpendicular like this. Okay, so there's our perpendicular. And when I make that perpendicular, now I've got a right angle here, 30-degree angle here, and so this is 60 degrees. Okay, so now we got a 30, 60, 90 triangle. Sorry about the messiness there. But there, that's 60 degrees. That's 90 degrees there and there. And now we have something we can work with. Okay, now we have some choices about what we label things. I'm going to go, we want to know what CE is. But rather than just, I could call it X and that 1/2 X, but I'm actually going to call it 2X just because I have a hunch that'll just make my calculations a little easier. So I'll call that 2X. We'll call that X. And we'll call that X times the square root of 3. All right, which makes this here 12 minus X square root of 3. Okay. At this point, we have some pieces of a proportion. So since I made this right angle here, and we know that's 90 degrees there, okay? We know that B is shared by this little triangle and by the big triangle. Then, and this is 90 degrees, this is 90 degrees, this angle is shared by both triangles. We have angle, so we can make a similarity statement for triangle BCA. We can say BCA, okay, is similar to, let's give this a letter, just like some folks I've been speaking to about this did. We'll call that F. Okay, so BCA and BFE. Okay, BFE. Big friendly echidna? I'm not sure. Okay, so these are both triangles, of course, so I'll make a little triangle symbol. Triangle BCA is similar to triangle BFE by angle. Okay, and so that is what that tells us. Now, once we have that information, we can say 5 is to X as 12 is to 12 minus X root 3. So we can say 5 is to X as 12 is to 12 minus X root 3. All right. At this point, I'm going to get Desmos open because Desmos is a little easier for me to type this sort of stuff. But this is the equation I'm going to be working with. And this is And my goal is to figure out what 2x is. So I'm just going to make a note. I want 2x. Okay, and I'm going to try and solve for 2x using this. So let's open up a Desmos. Shrinky-dink it a little over here. So I've got my equation visible. Make that the Desmos-y thing. Okay. Yes, yes. Just let me click my thing. Okay. And it appears it is not happy with me. So hang on. There. Now it's happy with me. And I will make it a little bigger. Boop, boop, boop. Because we don't need to see the graphing. We just need to see the equationing. So 5 over x equals 12 over 12 minus, and I'm going to call it root 3x now. Square root 3, oops, that's a 4, times x. And the x you'll see is outside of the radical. Okay, it's actually giving us an answer. It's decided it knows what the answer is over here. But I'm not going to pay any attention to that. And now I'm going to get the cross products. So I'm going to say 5 times 12 minus square root 3 times x equals 12x. I wonder if when we were working this out, we ended up getting the two numbers backwards. I don't know. At any rate, that's what we get. And now I'm going to distribute. I'm going to stretch this out a little bit here. So you know what? Now that I have my equation, I don't need to see that anymore. So there we go. Now we have room. So now I'm going to distribute the 5. So 5 times 12 is going to be 60. And then that's going to be minus 5 square root of 3. And then times x. And that will equal 12x. Now I'm going to add 5 root 3x to both sides. So I'll have 60 equals, let's copy this, like this. And that's going to equal that. I need to get rid of that equal sign. Now it's actually a plus. Okay. I'm going to copy pasta that and put parentheses around that thing. And what I'm going to do now is I'm going to factor an x out of there. Okay, so that x and that x came out. And now I'm going to divide 60 by this thing here, by this. Okay, so let me copy that. And I'm going to end up with, actually, let me copy the whole thing first. Okay, so this is going to be divided by this. And that's going to cancel it out. And this is going to be divided by it as well. Now I have to stretch this out. Up there. Okay, so over on the right, these cancel out. Oops, that's not what I wanted to do. That's what I wanted to do. So these go bye-bye. I'm just left with an x on the right. And we've got this mess over here. Now we've got to rationalize the denominator. And when we've got a radical in here like this, and it's a compound thing where you've got a whole number, some sort of rational number plus an irrational number, what you want to do is you want to use the difference of squares structure. So what I'm going to do this over this. I'm going to make some sort of version of 1. Let me copy this. And I'm not going to be multiplying by that. I'm going to be multiplying by its conjugate. So instead of 5 root 3 plus 12, I'm going to do 5 root 3 minus 12. And up here, I'm going to be using 5 root 3 minus 12. Okay? And so that's just 1. But when I multiply these two, what I'm going to end up with is the square of 5 root 3 minus the square of 12. That's a difference of square structure. Okay, so let me go one more level. So I'm actually going to copy this and we'll move this over. So the 60 becomes this. Okay, and I'm going to get rid of all of this. down here in the denominator, I'm going to end up with this squared minus this squared. That's the difference in squares. That's what you get when you multiply conjugates with each other. Okay, and we can go one more step. And the 5 root 3, well, the root 3 becomes a 3. And the 5 squared becomes a 25. So we end up here with 3 times 25 times 3. Rid of that square. And on the right, we end up with 144. Okay. Okay. Now that I've got that, I'll copy that, and we're going to tidy up the denominator. So the denominator is now 75. Oops. 75 minus 144. And 75 minus 144 is negative 71. There is an error that's snuck in here. I'm not sure where, because that should have been 69. Oh, I see. There's the error. I didn't type it right. There, negative 69. Oh, yay. I thought I was going to have to do a whole lot of stuff over again. So that's negative 69, but I don't like having a negative in the denominator. So what I'm going to do is I'm going to switch the direction of this subtraction and make that positive. So I make that positive. So I change the sign, and this is a neat trick you can do. Reverse the direction of the subtraction is a way to change the sign. So I've just migrated that negative there. Now, look over here. That's a 60. That's a 69. Both of those share a factor of 3. So we can tidy that up. I'll factor out 3 here. That becomes 20. I factor out 3 here. That becomes 23. And now we just need to double this, because what we really want is 2x. So 2x, double that, and over here, this becomes 40 times 12 minus 5 root 3. And let me confirm that that is the answer, because I did work this out earlier and confirmed it. It is 40 times 12 minus 5 root 3 over 23. And that is what CE is. Okay. If you would like to get, that's the exact answer, by the way. We could actually tidy that up a little more than that. If you want to know what that is as an estimated number, it's about 5.8. Blah, blah, blah. It goes on forever, because square root of 3 goes on forever. It does not have a consistent repeating pattern. And that is how long CE is. So let me go over here to this. So CE has a length of 40 times 12, confirm that I read that right. Yes, 12 minus 5 root 3 all over 23. All right, I hope that made sense. I hope that was helpful. And you even got to see me catch a mistake along the way that would have been disastrous if I had not caught it. But fortunately, I'd done it already, so I knew it was a mistake. All right, there you go. That's the answer, or about 5.8.